Hello students, welcome back to another exciting session of ICSE Physics Term 2. A very good evening to all of you. I hope all of you are doing well. This again is going to be a very exciting session, a very important session. Why? Because the title of the session says Important Board Questions of Current Electricity. See, current electricity has always been a difficult chapter for students who have problem in numericals. Okay. So what I have decided is in this particular YT session, I'm going to tell you only numerical problems. Okay. And if time permits, I'll be discussing few theoretical questions as well. That too only on current electricity, right? In case you're watching my session, you're watching my lecture for the very first time, let me first introduce myself. My name is Kalyan Krishna Awasthi, and I happen to be a physics educator at Unacademy, right? And these are my qualifications, these are my credentials. I'm a research scholar in electronics. I'm pursuing my PhD right now. I've done my master's as well in electronics, and I've been teaching physics since 2008. Okay, so the immense experience that I have in physics, I mean, all my students can take benefit of it. I have been into this ICSE teaching for quite some time now, so I have a very basic idea of which kind of questions they ask in examinations, what should be the strategy as well. Very soon I'll be coming with a strategy lecture as well. So let's see how it goes. These are the links for the Telegram channel. The very first channel is a general Unacademy ICSE and ISC board channel. I hope and wish that most of you have already joined this Telegram group. In case you're watching the lecture for the very first time, you can join this particular group, and this happens to be my individual group, my individual Telegram group, in which you'll be updated with all the upcoming sessions. And very soon I'll be updating you with the numerical questions, the MCQs, and the important questions, and I'll be rather sharing the strategical videos as well. Okay, it is very important to strategize the preparation for any exam, be it any exam. Okay, I mean, it is said well begun is half done, so it is important to start in a very good manner so that the journey is easier. All these tips and tricks you'll be getting on this channel as well. And for all my dear learners, this is a very good offer. In case you're planning to buy an Academy subscription, subscription, this is the right time, because for a 12-month subscription you'll be getting 2 months absolutely free. Yes, and on top of that you'll be getting 10% discount if you're using the codes. This is my code, Kalyan Live. This is my YT code, Kalyan Live. Okay, and a very important thing, that this offer is applicable for first 500 subscriptions only. So make use of this opportunity and subscribe, take subscriptions. Okay, now let us start the session without wasting any time. This happens to be the very first question for the session, and what does this question say? It says the VI graph for a series combination and for a parallel combination of two resistors is shown in the figure below, and they are asking which of the two, A or B, represents the parallel combination, and you have to give reason for your answer. Okay, fine, let's see. The question says that the combination, the graphs are for the combination. Okay, let us suppose we have got two resistors. In this type of questions you have to assume two resistors, R1 and R2. If they are in series, then R series. What is R series? R series will be R1 plus R2, and R parallel, I mean, if I connect them in parallel, then the equivalent resistance will be R1 R2 upon R1 plus R2. Now, a very important thing we know, in case you don't know, just note it down. In series combination, the overall resistance increases. Okay, yes, I mean, if you are having two resistances of different values, then the series combination will always give you a greater value than the greatest resistor that you are having. And the reverse happens with the parallel combination. The overall resistance is kind of decreases. Okay, now see, in this particular graph, if you look at the graph properly, the graph is between V and I. Okay, and the slope for any graph, I mean, I'm not talking about this particular graph, in general, if you are taking any graph, the slope is always y by x. Okay, so here you have to see which particular quantity is plotted at the y-axis. So at y-axis you can clearly see that voltage is plotted, and which particular quantity is plotted at x-axis, you can clearly see that a current is plotted. Okay, so the slope here gives you the value of V by R. And what is V by R? In accordance to Ohm's law, V is equal to IR. So V by I is nothing but R. That means what this question says, this question tells you that the slope of the curves will actually be resistance. Okay, the slope of the curve will actually be the equivalent resistance. Okay, see, parallel combination. Okay, they are saying which one is a parallel combination. Now see, what is the other method to find the slope? Slope is tan theta. If this is theta A, this is theta B. Let this be theta A, let this be theta B. That means this theta A and theta B are also the slopes. Yes, I hope you remember the equation of line y is equal to mx. What is the slope? Slope is y by x, and we represent slope by tan theta. You have studied this in maths, straight lines. Okay, the slope will always be tan theta, and for very small angles you can assume that tan theta is almost equal to theta. Okay, so see, what you have to do is you have to find which of the two angles is greater. If I'm saying theta A, theta B, you can clearly see that theta B is greater. That means slope of B is greater than the slope of A. Yes, and what does the slope tell us? I have just shown you that the slope of a VI curve will tell you resistance. So if slope of B is greater than slope of A, I can write that resistance of A is, the resistance of B is greater than the resistance of A. I can write it this way. Yes. And I have just told you that if the overall resistance increases, it has to be a series combination, and in case the overall resistance decreases, it has to be a parallel combination. So now you tell me which of the two graphs is appropriately representing a parallel combination. If the question is asking about the parallel combination, what you have to write in the answer, you have to show this mathematical explanation, and in your board examinations you have to write that we know that in parallel combination the overall resistance decreases. I'm telling you the entire answer, how you have to write it in your board examinations. Okay, so it says, we know that in parallel combination the overall resistance decreases, and next point mein you will be writing the slope of the VI curve gives us the value of the resistance. In the next line you will be write, from the figure we can conclude that slope of A is less than the slope of B. Yes. Next line, since the slope of A is less than the slope of B, so the lower slope should represent a lower resistance or a lesser resistance, and hence this should be a parallel combination. Yes, good to go. I hope all of you have understood. I have explained the answer in the best possible manner. I have given you the mathematical validation. I have told you how you will be answering it rather. Yes, I hope it is clear to all of you. Shall we move ahead? Okay, fine. Now this is the next question. And what does this question say? The question says a music system draws a current of 400 milliampere. Okay, let me see how to. The very first thing that you have to write is the current, which is 400 milliamperes, and it is connected to a 12 volts battery. The voltage is 12 volts. Okay, You might require calculators. It is allowed. Hi everyone who has joined the session. Okay, it does has a 12-volt battery. The very first part says what is the resistance of the music system. Okay, fine. So it's a very easy part. How do you find the resistance? V is equal to IR. This is the method to find the resistance. So I can clearly see that R is equal to V by I. Yes. So V is 12 volts and I is 400 milliamperes. So I have to convert it into amperes. So what will be the value of the resistance? It will be 12, 1, 2, 3 and 400. This gets cancelled. You will be getting 30 ohm. Yes. So this is how you will be finding the resistance. The very first part is done. Okay. Let's see what the second part says. The second part says the music system is left playing for several hours and finally the battery voltage drops. Okay. And the music system stops playing when the current drops to 320 milliamperes. Now, the question says, finally, I final is nothing but 320 milliamperes. So the current finally drops to 320 milliamperes. At what battery voltage does the music system stop playing? Now they are saying when the current has dropped to, see, this is the final value of the current. They are saying this value is achieved at which particular voltage. So now here the catch is, whatever value of voltage you're talking about, rather the resistance is a intrinsic property, right? So the resistance of the system will not change, and we have already determined the resistance in part 1. So what we can do is we can use the resistance that is determined in part 1 here, and again what will be the value of V? V is equal to IR. Now you have the value of I final and you have the value of R. So what you have to do is you just have to multiply it and this will give you the answer. Yes, I hope all of you have understood. Yes, I just need an affirmation in the chat box. Yes, all of you who have joined the session. In today's session, bacha, we'll be doing all numericals. Okay, if time permits, I mean if you have any doubt as well, you can ask in the chat box. Obviously related to current electricity, I'll be more than happy to help you out. Okay, fine. Let's see what the next question says. Okay, this happens to be the next question. Find the resistance between points A and B. Okay, you have to find the resistance between point A and B. So this happens to be a question of equivalent resistance. So how will you go about this question? See, whenever this type of question comes, you have to first analyze the smallest possible part. I mean, where there is a scope of conversion or maybe finding an equivalent resistance. Here you can clearly see that these three resistors are in parallel. Okay, and these two resistors are also in parallel. One more important thing, this time around you'll be giving a subjective examination. You have to write your paper, so you cannot afford to miss any step. Okay, so I'll be telling you how you should do this question so that in case you don't get a correct answer, you don't lose marks in the steps. You cannot afford to skip any step. See, how will you go about? First of all, you have to write, let us assume that these three, the equivalent resistance of these three resistances is R1. So now what is R1? You have to find R1. Yes. 1 upon R1 is equal to 1 upon 3 plus 1 upon 3 plus 1 upon 3. Now let me tell you, there might be a number of students, although I believe that by now you are able to identify whether a particular combination is in series or parallel. But in case you don't know how to find, I'll be telling you the trick. See, this is a sure shot method to get the correct answer. Whenever this type of a question is asked, always start a current. Okay, always start a current. At this point, see, the current is moving here, it gets a node. Now let me brief you what a node is. Node is a point where current breaks. Always remember this. Whenever you have any problem in any question, you're not able to identify whether the resistance, whether the combination excuse me, is in series or in parallel, you just have to do one thing. Just take a current, assume a current, and start breaking it. So here I current is coming. This happens to be a node. All of us have seen a node. I mean, the poles, very relatable example, outside our houses or the flats, you have seen a single wire comes and a lot of wires are, subsequently they move out. So when the subsequent wires move out, we have a node. The current breaks. The same thing is going to happen here as well. I current, now current has three paths. So I1 will go here, I2 will go here, and I3 will go here, right? Now just look at the question very, very carefully. Now this I1 is coming here. Here also it's I1. Here it is I2. And here it is I3. I hope all of you have understood this. Now just look at this node. I1 is coming from here, I2 is coming from here, and I3 is coming from here. So again here you will get current I. Yes, you can see here again you will be getting current I. Now this I will again be breaking into two current. Let us suppose I dash and I double dash. Okay, and I dash will come from here, I dash is coming here, and I double dash will come from here. Here again I dash plus I double dash you will be getting. And what is I dash plus I double dash? Here I was actually broken into I dash plus I double dash. So here again you will be getting I. You have seen how we are dividing the current. Now whatever resistance combination is having same current, they are in series. Whatever resistance combination is having a same potential, they are in parallel. In series, current is constant. Okay. In parallel, voltage is constant. Right? In series, current is constant. In parallel, voltage is constant. So you can clearly see these three. If I apply a voltage here, the same voltage will reflect across all three resistors. So they are in parallel. What will be the value? 3 will be the LCM. 1 plus 1 plus 1. This will give me 3 by 3 is 1. So what is R1? R1 is 1 ohms. Okay, so I've got the value of R1. Similarly, this 4 and 6 are in parallel. So let me call it R2. Let me call it R2. So 1 upon R2 will be equal to 1 upon 6 plus 1 upon 4. So the value of R2 will be 6 into 4 upon 6 plus 4. This will be 24 upon 10. This will be 2.4 ohms. Now, in the next step, you don't have to write the answer here. You don't have to do it this way in your board examinations. You have to write one more step. Now see, this was A. Yes. Now this was R1. This was R1 and the R1 value was 1 ohm. Here you are having a 5 ohm. This was 5 ohm. And then again you had R2. And then you had B. What was R2? R2 was 2.4 ohm. So now if I ask you what is the equivalent resistance between A and B? So you can clearly see that R1 plus 5 plus R2. Why? Because all these three resistances are in series now. You have to put the value of R1 is 1, 5, R2 is 2.4. So this will be 6 plus 2.4. This will be 8.4 ohms. So this is how you have to write in your board examinations. And a lot of students have asked me in the sessions, in the plus classes, in the special classes, sir, we know the answer directly. Should we write it directly? No, you don't have to write it directly. In term 2, there'll be a subjective paper, and whenever there is a subjective paper, there are step marking. There is step marking. Okay, so you don't have to miss any step. Elaborate your answer in the best possible manner. Okay, it has to be presentable, and if a particular examiner is checking your answer, he should immediately relate to everything. Okay, just make it a habit. This question becomes very tricky. Okay, I mean, not the complexity level. I have not taken this question because it was very difficult. No, it was very easy, but I took this question so that all my learners get to know how they have to write in the board examinations. Okay, I hope you have understood how to write it. Okay, let's see. Okay, we have one more question. What does the question say? The question says a house has main fuse of 5 ampere rating. Now, this seems to be from the electrical energy part. Okay, a house has a main fuse of 5 ampere rating. So, I main, the main fuse, the maximum value of the current is 5 ampere. See, very important thing, whenever the word rating comes in any particular question, rating means the maximum limit. Okay, the maximum limit, right? You have seen the speed limits. The speed limit means this is the maximum allowable limit. So if the rating of the fuse is 5 ampere, what does it mean? If a current greater than 5 ampere comes, fuse will blow. Yes, and it will not allow any current to pass henceforth. Yes, it's a very important thing. You have to remember this always. Okay, now what does the next part say? The next 5 bulbs. Okay, bulbs, how many bulbs? We have 5 in numbers. Okay, each of 60 watt. The power of the bulb is 60 watt. Okay, and what else we have? We have tube lights. Okay, tube lights. And how many tube lights we have? 2 tube lights. So you have to write 2 tube lights. Okay, always write this in your answer. I have told you in the strategy video as well. Always remember this. Whenever you are answering a particular question, don't forget to write the given quantity. It is very important. You should write which quantity is given. Always remember. Fine. So, and power, what is the power of the tube light? The power of the tube light is 40 watts. Okay, well and good. How much current is drawn from the main of 220 volts? Okay, they have given you that the main voltage is 220 volts. Now they are asking how much current is drawn. So this question becomes very relatable. How will you determine the amount of current that is drawn? Okay, yes, Ridhima, you can write R1 as RP to represent the resistance in parallel. I'm sorry I couldn't see the message that time. I was busy in the question. Yes, Ridhima, you can very well write it. Okay, there is not a problem. Good evening, everyone. Good evening, Aman. Good evening, Ridhima. I hope you guys are here. I couldn't see the messages because I was kind of busy with the question. So in case you are here, just hi. I'll be okay. Fine. It's a very good question. This question is a very good question. It will clear a lot of concepts. Fine. So how much current is drawn from the mains? Now you have to find how much current is drawn from the mains. See what happens. The bulb will draw separate current. Why? Because the power is different. The tube light will draw separate current because the power is different. Now you have got 5 bulbs. So total power that the bulb draws, P total for bulb, what will it be? It will be 60 into 5, 300 watts. Okay, 300 watts of power is required by the bulb. Yes, and how much power is required by the tube light? P total tube light. There are 2 tube lights of 40 watt each. So this is 80 watts. Okay, so now tell me, what is the total power that is drawn? I mean, from the entire supply, P grand total is 300 plus 80 is equal to 380 watts. Okay. Yes, all of you in the session. The total grand power that is drawn is 380 watts. Yes, I hope it is pretty much clear to all of you. Now, what is the main supply? The main supply is 220 volt and rating, and they are asking you the current. So how will we go about? We'll be using, let me see, has anyone replied? Okay, I guess. Okay, P is equal to V into I. So what will be the value of I? I will be P upon V. What is P? What is the grand total power? It is 380. And what is V? It is 220. So whatever value you get here, that will be the answer. I mean, I can tell you an approximate answer. It will be 1 point something. Okay, 1.7 around. Approx. You can calculate it. Approximately, it will be 1.7. Okay, but you can calculate it in the perfect value, right? I hope the first part is pretty much clear to all of you who are in the session, who are watching this particular video. Yes, come on. Yes, I hope yes. Okay, fine. Let's see what the second part says. The second part says how much more bulbs. Okay, now this becomes interesting. The question says how many more bulbs, each of 100 watt, can also be lighted on a festival day. I mean, if there is a festival and they are asking that 100 watt is the rating of a bulb, and how many more bulbs can be lighted or maybe lit. So in these type of questions, how to proceed? See, very first thing is you have to see how much current will a 100 watt bulb take, right? If I get the value of current that a 100 watt bulb is taking, half the work is done. Okay. Yes. Now here, current, it's a very good question. Current required by 100 watt bulb. Let me see if I have a blank sheet. Okay, I don't have one. By a 100 watt bulb, how much current will be required? You know that V is equal to P is equal to VI, so I will be equal to P upon V. What is the wattage? Wattage is 100, and what is the voltage? Voltage is 220 rather. Yes. So whatever value it comes, I mean, if you are attending this session, you can tell me the value. I mean, it will be great if I get to know the values. Okay. It will be 0.45 amperes. I have used my calculator to calculate the values, and let me calculate the previous value as well, the exact value. It was 380 divided by 220. It was 1.7272. So I should rather write 1.73 amperes. Okay. Now see, a very, very, very logical question. Now, more than physics, you have basic general knowledge. Okay. Let's see how it. This much current was already used by the bulbs and the tube lights, and the main current is 5 amperes. You're getting my point? See, the question already said that the main current is 5 ampere. You cannot use the instruments or maybe the appliances which are drawing more than the rated current. So first of all, you have to find how much current is actually available now. Yes. So available current is 5 was the rating, and you have already consumed 1.73 amperes. Yes. So how much current is left? It is 3. This will be 27 ampere. Okay. So this much current is left. You can connect appliances in such a manner that only this much current can be used. Beyond that, obviously the fuse will blow. So can anyone tell me how to go about? See, this much current is available, and this is the current rating of a bulb. I mean, if I connect one bulb, just try and focus. If I connect one bulb will consume, let me write it here, one bulb will consume 0.45 amperes of current. And how much current is excess that can be used? The excess current is 3.27. So how many bulbs can be used? It's very easy, common sense. Number of bulbs will actually be the total left current divided by the current that a single bulb can use. Yes, you have to solve it. Let me see what the value comes. It is 3.27 divided by 0.45. Okay, 0.27 divided by 0.45. This gives you approximately 7.26. Okay, now you cannot use 7.5 bulbs, or can you? No, you cannot use. So whenever this type of question comes, you have to take the nearest integer. Okay, the nearest integer is 7. So with this case, you can use 7 bulbs. I hope the question is clear. Hi Chetna, how are you? See, this time around we are having questions. So if you are interested, you can stay in the session. Ridhima, Chetna, Aman, all of you understood this? Yes? This was a very, very good question. Very good question. Okay. Now let me brief you about, see, you're watching this lecture on YT, and I would rather suggest you to download the Unacademy app and attend a free session there. Free special class. We call it special class, and let me brief you about the features that we are providing in a special class. You get to interact with the educator in real time. Like, see, there was a miscommunication. You were sending something and I received it later, so we couldn't interact live. Had we both been interacting live, I mean, I would have addressed Ridhima and Aman's doubt then and there, right? Doubt, rather, it's not doubt. I mean, whatever they were saying, yes, you can write parallel as RP. There's no problem in it. So in a special class, you don't have this problem. You will interact with the educator live in real time. You can chat with me and you can use emojis as well. Okay. And again, a very interesting part is you have the question tab. Okay. You have the question tab at the extreme right corner. You can use that tab to send me a question if you have any problem. I mean, let us suppose Ridhima is solving a question which looks similar to this question. I mean, the question that we have discussed. Let's say this question, and she's facing a doubt. I mean, she's not able to get the answer, or maybe this question, she's not able to get the answer. So what she can do is she can immediately send me the snap. Yes, there is an option of attach an image. She can, yes, Piyush Kumar Gupta, it is for 10th. Resistance is for 10th. Yes, you are in 9th. You can attend the session. No problems on that. We have a session for 9th immediately after that. Hi Chetna, how are you? Good to see you, beta. Very good. How are you? I'm fine. So you can rather ask a question in the real time. This is a very good thing. And we conduct polls as well. And what are polls? Polls are the important questions, the important board questions that we take up through MCQs. Okay. So, and on top of that, we have got leaderboards. What are leaderboards? Leaderboards is a replication of your performance in a particular session. I mean, how many questions did you get correct? How much time did you take to get those questions, to solve those questions? See, accuracy and time management, I keep telling all my learners in all the sessions, they are the key points for getting success. Okay, you have to be accurate and you have to manage your time. The entire Unacademy portal is designed keeping these two aspects in mind. Okay, so in every poll board you will get the number of accurate questions. हाँ मिस्टर पीयूष कुमार गुप्ता, मैंने आपका क्वेश्चन बना दिया है. एंड टुडे आल्सो वी हैव अ क्लास, वी हैव अ स्पेशल क्लास ऑन प्रोपगेशन ऑफ साउंड एट 7:45, और इसी का वील बी हैविंग अ पोल. I mean, the next poll is on propagation of sound, rather, on 14th of Feb. Yes, so I would love to have you in the class. Okay, you never know. I mean, I might give a question from the class only. No, Chetna, you're not new. You're not new. उसमें तुम्हारा question, okay, okay, maybe if you want, I can add one. There's no problem. Maybe I can add one. So you can attend the class. I mean, it's a one-shot class. I mean, the next class that I'm having, the special class, it's a one-shot class. So you can attend it. You'll be able to revise the entire chapter. For all the students, for all the class 10 students who are watching this lecture, we have come up with one-shot revision lectures and poll wars. Okay, so I mean, I would suggest all of you to attend those sessions. Just attend a single poll war, and believe me, you'll have a lot of fun and knowledge as well. You can ask from the ones who have already attended. The poll wars, they are amazing. I take a lot of time to design questions. Okay, they're not the copy paste questions that you find everywhere else. No, every question is connected to a learner, and that can be verified rather. Okay, fine. So these are the special features. I mean, these are the features which make the special class at Unacademy stand out in comparison to any other class. And the best part is that's absolutely free. Okay, see, if you want to, if you're downloading the app, what you have to do is, if you want to watch a physics session, you have to type my name, Kalyan Krishna Awasthi. This is my name. You'll find me there in the physics sessions. Okay, and you'll get all my special classes. Okay, ऐसा नहीं है, we have had a number of special classes. Okay, thanks Chetna. So you can attend a special class and you can use my code. This is my code, beta. Kalyan Live. Kalyan Live. Kalyan Live. This is my code. You can use this code. Okay. Once you use this code, all my logged classes will be unlocked. Okay. Sabhi kuch special is free for you. If you're watching this session, you're finding the questions interesting, I would recommend you to attend any of the special class. Trust me, you'll be a permanent member after that. Okay. Okay, a very, very important announcement rather about the Unacademy Prodigy test. See, Unacademy has come up with a very interesting idea of having this Prodigy test. The next test is happening on 13th of Feb. Okay, so I would ask all of you, I mean, I hope and wish that most of you have already enrolled for the test and maybe given the test. But in case you have not enrolled for the test and you haven't given the test yet, just enroll. The enrollment is absolutely free. There is no harm in giving the test. You know, why am I saying? Because you might get an opportunity to win these prizes. I mean, this, hi, all time best. Hello, hello. Good to see you after a very long time. How are you, beta? All well? This is the schedule for the test on Feb 13. Okay, the class wise bifurcation is given here. So you can, what you have to do is just enroll for the test. Okay, just give the test. It is for your benefit only. See, these are the prizes, these are the rewards that you might win. See, rank 1 holder will win a MacBook. From 2 to 3 you will be getting, rank 2 and 3 you will be getting an iPhone. And from the rank 4, okay, you were attending my special class. Yes, I know you were attending my special class. 7th class ka Chitna, at the end of the class, I'll be sharing you a number. Okay, that number is for the YT counselor, this Unacademy counselor. So you can talk to them, you can get your queries resolved, whatever issues you have, whatever queries you have regarding, you know, the subscription or the courses, whether or not they are live. Okay, your name is Mohammad Ashar. Okay, Mohammad Ashar, you didn't attend the last poll. I still remember. I had a question on your name and you were not there. I mean, I had 2 questions if I'm not wrong. Mohammad Ashar, I had 2 questions on your name. And the rank 4 and 5 will get a chance to win iPad. From rank 6 to 40, you get Amazon Echo Dot. And for rank 41 to 100, you get a chance to win Amazon vouchers. Yes. And these are the scholarship slabs. Just look at the scholarships that Unacademy Prodigy is offering. So you have nothing to lose, rather. Yes, Bachawati, you have nothing to lose. You will get a chance to keep a check on your performance. It's absolutely free. All you have to do is just enroll and attempt the test. I'll be telling you at the end of the session. I have that slide, beta. Okay, I have that slide. And see, these are the two batches that we are having for class 9th and 10th, the champions batch, in which I'll be teaching physics. Okay, in both the batches the mode of delivery will be English. Okay, and if you're class 9 student, you're opting for you're taking a plus subscription, so you'll be getting an added advantage for 10, 11 and 12. If you are a 10 student, you'll be getting an added advantage for 11th and 12th. So this does add value to it. These are the special Unacademy, the best features for Unacademy. What are they? You get to learn live at the comfort of your home. There is unlimited access to all the courses. All the courses can be accessed unlimited number of times. Obviously, top educators are there, and every fourth session is a doubt clearing session. This is very important thing that Unacademy has come up. You have sessions exclusively to get your doubts cleared. All the topics, the entire syllabus is exhaustively covered with all the topics. I mean, we don't leave even a single line from your textbook. These are the other added advantages. Okay, now let's get back to the question. Okay, we have had enough of this. Okay, you want me to okay, let's see. This is the question, and the question says calculate the equivalent resistance between the picture A and B, and in the following combination of the resistors. Fine. So now again we have to use this trick, the trick that I've told you. If you are confused whether the resistances are in series or in parallel, what you have to do is you have to use a very simple trick. Take a current from here, okay, and divide it. Let me suppose I1 goes here, I2 goes here, and this I3 goes here. Now just see one thing. Okay, Muhammad Ashar is telling 13 ohms. Let's see, Muhammad Ashar. This is I1, this is I1, this is I1, and this is I1. All three are I1s. Okay, so when the current is same, the resistance are in series. So value of R1 will be 4 plus 4 plus 4. This will be 12 ohms. Okay, yes. All the students should answer. Whoever is attending the session, they should answer the question. Now let's see. This current is I3. Here it is I3. Here it is I3. Here it is I3. So these three resistances are connected in series. So R2 will be 2 plus 2 plus 2. So this will be 6 ohm. Okay. Muhammad Ashar, see, when you are writing a subjective exam, you have to elaborately write the answer. Okay, so how will you go about? Now I have to redraw the circuit, and what does the new circuit says? You don't have to skip any of the steps, beta. Every step has a mark. Okay, now see, 4 4 4 4 4 8 12. So there you have a 12 ohm resistor. This is a 12 ohm resistor. Here you have a 4 ohm resistor, and here 2 2 2 2 4 6. So you have to draw it. If you want to score good marks and full marks, see what happens. That is why I keep telling all my students. I know most of you know the answer. Dekho, I'll tell you a very interesting thing. I often tell this in the special classes, but see, there are two educators. Educator 1, he is very knowledgeable. He knows everything, but he is not able to present it properly. you know, I mean, you can feel, you're watching him, you are attending his offline classes, you know that sir is or ma'am is very knowledgeable, but sir or ma'am is not able to convey what they know. Then you have another educator who might not be as intelligent as the educator one. I mean, he or she might not be that qualified, that intelligent, but he has a quality. Whatever she knows, he or she is capable of, explaining everything to the student, whatever they know. I mean, I have assumed that both the educators know the correct concepts. Now tell me, which educator's class will you preferably attend? The one who is very intelligent, or the one who is able to explain you everything, whatever he knows? Whose session will be more interesting? Be it online, be it offline, be it anywhere. Come on, tell me in the chat box. Whose sessions will you be attending? Obviously, the second one, who is able to represent whatever she knows in the best possible manner. So, yes, now you told me the answer might be correct as well, and I know that most of these students find these questions easy as well, that's no problem. But you have thought, I mean, you thought that you'll be getting 2 out of 2, but you end up getting 1.5. Why? Because you didn't mention these steps, right? So this is what I was talking about. Now you have to write that these three are in parallel. So let us suppose this is R3. So what is 1 upon R3 is equal to 1 upon 12 plus 1 upon 4 plus 1 upon 6. Okay. Can you tell me what is the value quickly while I'm drawing R3? Anyone in the session who is attending the session? This is A, this is B, this is 5. What is the LCM? This is 5, this is 6, and this is your R3. Now, whatever value of R3 you get, whatever value you get, you have to solve it. I hope it's very easy. Yes, don't have any problem in this rather. So what will be RAB? Value of RAB 5 plus 6 plus R3. That is 11 plus R3. Whatever value you get. Okay, fine. Okay, I hope the question is clear. Let's see what the now this again. In this question, they are saying the equivalent resistance of the following circuit is 4 ohm. I mean, they have given RAB and this is 4 ohms. Okay, well and good. And you have to calculate the value of X. So how will you go about this? First of all, you have to write it A. Here, you have to draw a resistor whose value is 5 plus X. Here again, you have to draw a resistor. This is B. Here the value is 12 ohm. Now you can clearly see that 5 plus X and 12 are in parallel. Okay. So RAB is equal to 12 into 5 plus X divided by 12 plus 5 plus X. RAB was 4. So 4 is 60 plus 12x divided by 17 plus x, right? I hope now you will be able to solve it. It's very easy. It's a very simple equation. You can find the value of x by cross multiplying. This will be 4 into 17 plus x is equal to 60 plus 12x. Okay, 68 plus 4x is equal to 60 plus 12x. Yes, come on, tell me the answer, whoever is in the session. It's very easy now. So you'll be getting 8 is equal to 8x. So this will give you the value of x. Okay, this is how we move about these questions. It's very, very easy. Now again, very important announcement. Unacademy has come up with Ace Your Finals. This is a test series for all class 9 to 12 students for term 2, and you'll be having periodic and regular tests on physics, chemistry, maths and biology, right? The duration of the test shall be 60 minutes. I mean, the every test will be having 30 questions, and the tests will be conducted every Saturday and Sunday, so that they do. Yes, very good. I've seen your answers. Both of you have given the correct answer. The tests are on Saturdays and Sundays, so you don't end up, clashing your tests with your school timings. Okay, so this is a very good chance for all of you who are term 2 aspirants, because you get a chance to check your performance, to verify whether or not you're performing good. Okay, now let's see one more question. It's a very interesting question. The question says, calculate the reading of the A. What is A? A is an ammeter. Yes, A is an ammeter. And what does this ammeter do? It measures current. It measures current. Okay, the ammeter measures current. Let me see who tells me the answer first. All of you who are in the session, I just want the answer. The very first question says, the very first part says, K is closed. I mean, as soon as you close the key, K, what will happen? Now, this 4 and this 8, both the resistances are active. You're getting my point? Once you close the key, the circuit is complete. Okay. Once you close the key, the circuit is complete. It's a very important thing. The circuit is complete, and as soon as the circuit is completed, now this 4 and this 8, they are in parallel. And what will be the equivalent resistance? This will be 8 cross 4 divided by 8 plus 4. Yes? 32 upon 12. 8 by 3 ohms. So you will be getting the value of RAB as 8 by 3 ohms. So now what I can do is, I can replace these two resistance with a single value. And that value will be 8 by 3 ohms. This is 10 volts. Okay, now this is an ammeter. What will be the value of ammeter? Ammeter is reading current. It will be V by R. So V will be 10, R will be 8 by 3. This will be 30 by 3 amperes. Okay, yes. Now the first part was easy. Now the second part, a number of students get it wrong, and let me tell you why. Once you open this key, this 4 ohm is of no use. No current will move in the 4 ohm. Yes, no current will move in the 4 ohm. Yes, very good, Chetna. 30 by 3 is indeed the correct answer. Tell me the answer for the second part as well. Very good, very good. Tia is saying 30 by 8A. Yes, Tia, very good, very good. In case 2, the answer will be 30 by 8A, because this one is not in use anymore. Why? Because the key was open. So my circuit here, see now, in board examinations, I am again telling you, you have to write properly. So you have to redraw the circuit. And how will you be redrawing the circuit? This is how you will be redrawing the circuit. This is 8 ohms plus minus 10 volts. Okay, right? So I knew, what will be the value of I knew? It will be 10 by 8 amperes. Yes, very good. I guess most of you have understood it. Tia, if you have missed the session, just watch it. I have taken up very, very good questions. Now again, I was waiting for this question. A metal wire of resistance 6 ohm is stretched so that its length increased to twice of its original length. Okay, let me see. Let us suppose R1 is 6 ohm. Initial length, this is how you have to write it in your board examinations. Initial length is L1. Initial area is A1. Okay. So what is resistance? R is equal to rho L upon A. You have to write this formula and you have to say rho is resistivity. Okay. Rho is resistivity. It will be constant. Why is it constant? Because resistivity depends only on the material. Okay. Resistivity depends only on the material. It does not vary unless you are changing the material. Okay. So see, how will it go? They are saying its length is increased to twice. That means L2 is equal to 2L1. But what about A2? My question is what will be the value of A2? They have not given it. See, the very basic logic is, let me consider this as a wire. I hope all of you can see this stylus. If I am stretching this wire, yes, obviously the length will increase, but the area of cross section per unit length will also change. The parameter that will not change is volume. Volume will not change. Yes, volume will not change. So initial volume is, see, volume is area into length. Yes, so initial volume is A1 L1, final volume is A2 L2. Okay, this is what we have to do in every type of question whenever you get this kind of a question. Now see, let it be A1 L1, and in place of A2 let it be A2. In place of L2, what I can write is 2L1, because it was given that the length has become twice. Yes, so this L1 gets cancelled, and what I get here is A2 is A1 by 2. Very good, Tia. Very good, Chetna. Both of you have given the correct option answer. Now what was I supposed to find? I was supposed to find the resistance. Now resistance is rho L upon A. So R1 upon R2 is rho upon rho L1 upon A1 divided by L2 upon A2. See, I have taken rho as constant. I have taken rho as constant. Okay. So R1 upon R2 is L1 upon L2 into A2 upon A1. Okay. Now what I have to find? I have to find R2. R2 is what I was supposed to find. So let's make R2 as subject. So R2 will be R1 into L2 upon L1 into A1 upon A2. Now I know everything. I just have to substitute the values. Chetna, we are already discussing only numericals. Only numericals. So there's no point going with the MCQs. 6. L2 upon L1. L2 upon L1 will be 2. Yes? L2 upon L1 will be 2. Come on, now tell me the answer. I hope I am expecting an answer from all of you. I'm expecting an answer from all of you. 2. Okay. So the resistance will be, the new resistance will be 24. Now there is a very important rule. Always remember this. Always remember this. Let me change the okay. If a wire is stretched by a factor n, resistance changes by n square. Okay, always note this. This will help you solve the questions in a better way. Okay. Okay, now This was the slide I was talking about, Chetna. This happens to be my code. Kalyan Live. Writing it here. Kalyan Live. This is my YT code. You can use this code to avail 10% discount, or you can use. Hi Srija, how are you? Welcome to the session. I mean, you're very late. I guess you were there in the session. And this is the counseling part, the counselor part that I was talking about. In case you have any doubt regarding the preparation strategy, or maybe the subscription part, or the latest offer that Unacademy is having, you can very well use this mobile number. You can call on this number and get your doubts resolved. Okay, it's a very good opportunity. So I mean, none of the doubts should be left unresolved. So these are the Unacademy plans that we have for our learners. Just look at the plans and you can use this code. If you're using this code, you'll be getting 10% discount. A very important thing, a very strategic thing here is, as you move up for a higher duration subscription, the amount subsequently drops, and on top of that you'll be getting 10% discount as well. Okay, so these are the timings for my special class, for my special 10th classes. The next class is falling on 12th, that is tomorrow 6:30 p.m. It will be a pole war. It's going to be very, very, very exciting. And then on 16 there'll be a pole war on electricity. On 17 there'll be a pole war on electromagnetism. So we have got 3 pole wars lined up. I hope and wish that all of you attend those pole wars. It's going to be really very, very, very interesting. Okay, thank you. That is all from my side. Okay, I have one more question. Let's see. 2 bulbs are marked. Okay, P1 is 100 watts, V1 is 220 volts, P2 is 60 watts, V2 is 110 volts. Calculate the ratio of the resistance. P is equal to V square upon R. So R is equal to V square upon P. Yes? So this is 220 square upon 100. This is R1. R2 will be V square upon P260, right? So what you have to do is you have to find the value of R1 upon R2. It's very, very easy now, right? Okay, that's all from my side in this particular session. In case you have not subscribed us on YT, just subscribe the channel, click the bell icon. You can download the content, and I want to see you all in the next session, in the next YT session. Let me tell you when I'll be having my next YT session. Today is 11th. I'll be having my next YT sessions on Sunday 3:30 p.m. and I'll be teaching you atomic structure and radioactivity in a single shot. So that is going to be a very, very interesting lecture. Hope to see you all. Thanks everyone.